Okay, so on Canvas, like I said, we're starting topic 5, which is called energetics. Sometimes you also hear it called thermochemistry. And so for today, we're going to do kind of some intro stuff. So we're going to talk about the differences between heat and temperature. We're going to talk about this term enthalpy and what that means. But next time, we'll be doing some calculations with enthalpy. And then we're going to talk about the differences between endothermic and exothermic reactions. And in terms of kind of the energy that's being going on, and also in terms of some graphs. And so we're going to look at some graphs so we can tell the difference between these two types of reactions and what they are. And so you have kind of a note check, because after you've watched those videos and we've gone over some stuff in the live class today, you will have on pages 3 and then 5 and 6, that's where you'll be sort of annotating your notes. So you should be kind of adding in information, labeling, drawing, if you need to like color code things, all that kind of stuff on those pages. And then there are some exercises on page 4 and then on pages 7 and 8 at the end of this part that we're going to talk about today. And so what you'll do is, after you've annotated your notes on pages 3, 5, and 6, and then you've done the exercises that are on 4, 7, and 8, then you'll use that Adobe Scan app to scan all those pages 3 through 8. And you'll upload that PDF here to submit for your note check. And so I'm calling this note check 5.1 because we're starting topic 5, and this is the first note check in this section. Okay. So I'm going to go ahead and switch over to the iPad, and so we can go over some of the notes. So the reason that we kind of are skipping ahead to topic 5 is because I want to get through some of the information that's in topic 5 and 6, because here in a few weeks, you guys are going to be starting to do your IAs, which is your big sort of lab investigation type of thing. And so you have some options where you can choose to do it kind of online. But as we're going to talk about here in a few weeks, really like the best option is if you can come to do it in person, because then you have access to all the chemicals, all the equipment that's here at school. You have access to me to get help. But we'll talk about, there are some options where you can do it virtually. It's just they are a lot more difficult than if you were to come here in person and do it. So as we go through topic 5 and then some of topic 6 over the next few weeks, keep in mind a lot of the different things that we're talking about, because these could be potential techniques that you could use to do a research lab. Okay. One of the things we talked about last semester when topic 1 was stoichiometry were things like titrations. So things with solutions and titrations are good techniques. And then some of the things we're going to talk about in topic 5 with measuring heat and temperature changes can be used. And then when we get to topic 6 and we talk about rates of reaction, there are some things there that are also good techniques. So these are just some ideas to give you guys some background for when you're thinking about your lab experiment in a few weeks. Okay. All right, I'm gonna switch to the iPad and we're gonna start talking about topic 5. Okay, so as I said, this is what it should look like, this page, Energetics SL. So if you wanna add topic 5, because that is the number for this one. And then kind of here it has sort of a summary, and it has kind of these 2 sections where it has understandings and then it has applications and skills. And so I was telling the HL students last class that the understandings are sort of like, these are like definitions, or these are things that you should know, things that you should be able to understand and describe. And then the applications and skills is kind of a little higher level. So these are things where you're going to take those understandings, take the knowledge, and you're going to actually apply it and do something with it. And so we're not going to get to a lot of the applications up today, because we'll get to some of that on Thursday and then some of it next week. But one of the applications in this one is that we're going to be doing some calculations with some different equations. And then we'll actually be looking at a lab experiment called a calorimetry experiment. And so that's that technique I was mentioning that could be used potentially in a lab experiment for when you are doing something. So we're going to kind of focus on the first section today, because most of the stuff we're doing today falls into that. And then it has some guidance here. These are just things that we should make sure that we include. And so like we'll cover different things and as we go, and those will kind of all kind of pop back up as we go through the information. So you have this kind of checklist, and I was telling them in the last class that basically this is kind of a checklist for you to use to kind of self-assess how you're doing. And so what you would do is over here on the left side, it has kind of a statement. So it says like outline the difference between heat and temperature. So, you know, are you confident? Do you like maybe feel somewhat confident? You just need to review it and practice it a little more. Or is it like you don't understand it all? You really need to get some extra help or do some more studying or whatever. So based on sort of as we're going through and as we're going over information in the notes and your practice and all that kind of stuff, you want to kind of maybe check back on this list. And so like today, we're going to cover heat and temperature. Okay. So at the end of today, you should be able to kind of tell me like, how are you feeling with this? Are you feeling confident? Do you need some more practice and review, or do you really still not understand it? Okay. And so, and then like, we're also going to do, you know, the next few, the conditions for enthalpy change, the characteristics of exo and endothermic, and then sketching the diagrams for endo and exothermic. So those first four we're going to talk about today. And then as we go, we'll kind of cover more of them. And so you can kind of keep track about what do you need to maybe really study and focus on before we get to the test? And then what are things that you're like, oh, I got that. I don't need to, you know, really look at it again. Okay, so we're going to talk first about heat and temperature. They are two different things. A lot of people confuse them or use them in the same terms or the same definitions, but they are different, okay? Heat is the transfer of energy, and it always goes, this is really important, it always goes from higher temperature to lower temperature, okay? So heat flows from high to low, and that's what this diagram down here is showing. If I have two objects or two substances and I put them together, then the heat is always going to flow from the warmer object to the cooler object. And so what happens is the warmer object will drop in temperature and the cooler object will increase in temperature. So you can see on these little thermometers, this one, the level is a lot higher. That's indicating that it's at a higher temperature because it has more heat. And so when I put it next to an object that has a lower temperature, like this, then that heat is going to transfer, that energy, it's going to transfer, and I'm transferring it from the higher temperature to the lower temperature, okay? Heat is measured in joules, and it's abbreviated by that capital J, okay? You can also have kilojoules, so you can also have kJ, kilojoules. And if I need to go between joules and kilojoules, then I divide by 1,000, okay? So joules to kilojoules, I would divide by 1,000. If I go the opposite way, if I go kilojoules to joules, then I multiply by 1,000. So you need to know that because you will have to use those conversions at different times later on in this part. And so I kind of already talked about that the diagram shows heat always flows from hotter to cooler until they reach what we call thermoequilibrium, which means they end up at the same temperature. Temperature, okay? The definition of temperature is that it is the measure of the average kinetic energy of the particles, okay? And notice that this is absolute temperature. Absolute temperature means that it has to be in Kelvin, okay, not in Celsius or Fahrenheit. So absolute temperature, which is measured in Kelvin, it's the measure of the average kinetic energy. And kinetic energy is the energy of motion. And so what will happen is we might see some diagrams like these particle ones right here. And what they are showing us here is these particles over here on the left that have longer arrows, they have higher kinetic energy. The ones that are over here, the arrows are a little bit shorter, so they have lower kinetic energy. So they'll always draw the arrow to be sort of representative of the amount of kinetic energy. So longer arrows means they're higher kinetic energy, so they're moving more, they're moving faster. And then shorter arrows indicate lower kinetic energy because they're moving slower and they have lower temperature, okay? So kinetic, absolute temperature is a measure of the average kinetic energy. So if you are told, you know, kinetic energy, then you can figure out which substances are going to be warmer or cooler, have a higher temperature or lower temperature. Just like with these images, it says which sample of gas has the highest temperature, And then it says the gas particles in the left have the higher average kinetic energy and therefore a higher absolute temperature because they are directly related. Temperature is measuring that movement and that kinetic energy. We need to remember how to convert temperatures. So we did this in topic 1 when we had to do gas calculations, but if you don't remember, just remember that if we're converting between Celsius and Kelvin, you either add or subtract 273. So if I have Celsius, I'm going to add 273 to get to Kelvin. If I have Kelvin, I will subtract 273 to get to degrees Celsius. And that's important because a lot of times when we measure in the lab, we measure in Celsius. And so a lot of times they'll give you Celsius in problems and you have to convert to Kelvin before doing calculations, okay? So here's where you have some of the exercises that relate to heat and temperature and kinetic energy. So that's what you will do on your own for part of your note check. I'm going to move on here and talk about the basic of what is enthalpy and enthalpy change. And so this term enthalpy, it is the heat content of a substance, okay? And so we can't actually measure enthalpy itself. So really what we use is we use the enthalpy change. And so enthalpy is represented by this symbol that's a capital H. And so when I do change in enthalpy, I use the Greek symbol delta because that means change in. And so change in always means I'm subtracting things. And so change in enthalpy, that is the amount of heat that's either absorbed or released in a chemical reaction, okay? And I can use what it's called the standard enthalpy change of reaction, which means that I have this delta H, but it has this little kind of superscript 0 here because that means that I'm specifically talking about the enthalpy change of a chemical reaction. And that's the enthalpy change measured for whatever chemical reaction I'm talking about under standard conditions. And so it talks about in the pre-recorded videos that standard conditions are always going to be this temperature and this pressure. So it's 100 kilopascals and 298 Kelvin, which is 25 degrees Celsius. Okay, that's like basically like room, kind of like room temperature. So just standard conditions. If you're out, in the room or in, anywhere on Earth, typically that's going to be standard conditions. If you're at places that have like higher altitude, like in the mountains, obviously that'll change. But most places that's going to be your standard conditions. Okay, so the last thing we're going to talk about is what's the difference between endo and exothermic reactions, okay? So there are some kind of key things that we need to know about them. So exothermic, because that's on here first. Exothermic is heat flows from the system to the surroundings. And so what you can kind of think of it is you can kind of think of like exo looks like exit, and the heat, if you look at these arrows, they're all pointing out. The heat is exiting, it's going out to the surroundings, out to like the atmosphere. Endothermic, on the other hand, endothermic, the heat is flowing into the system. So now if you look at this one, all the arrows are pointing inward. And so it's like it's going inside. So kind of think of like endo, kind of sounds like inside, and exo sounds like exit. And so that's what happens. It's the direction of the heat flow. So exothermic heat's being released and endothermic heat is being absorbed, okay? And so here, the terms system and surroundings, system refers to the reactants and products. So the system is your chemical reaction. The surroundings are everything else outside of the system, okay, including the rest of the reaction mixture that is not part of the reactants and products, okay? So like if you have water or something like that that they're dissolved in, that's part of the surroundings technically. So let me write up here. So we are releasing heat here and we are absorbing heat here. That's the key difference, is the direction of the heat flow. And so how we relate this, because we relate this to this specific type of graph, it's called an enthalpy diagram, or sometimes you'll just hear it called an energy diagram. But basically what it has is you'll have a graph with like an X and a Y axis that looks like this. And you'll have the X axis will always be like the reaction progress. So it's like how the reaction's proceeding over time. And then the Y axis is always going to be the enthalpy or the energy. Okay, so it'll be measured in joules or kilojoules. And so what happens is you have your reactants, okay? Your reactants start with, and they have a certain amount of enthalpy because in their chemical bonds, they have energy that's contained. And so then after your chemical reaction happens, your products, they end up with a different amount of enthalpy. And so on this diagram, if I look, this line, this arrow is pointing downward. And so that means that the products have lower enthalpy than the reactants. And that means that they are more stable. So lower enthalpy means more stable. And that means that if I were to subtract, my delta H is going to be negative. So exothermic reactions always have a negative change in enthalpy. They have products that have lower enthalpy than reactants, and they have products that are more stable. And so when I say the delta H, what I would do is sometimes maybe they put values in here, like maybe this graph is labeled, and so like we have like 50, 100, 150, 200. Okay, so the graph may be labeled, and they might ask you like, what's delta H, and so I would have to look. And so if products are about here and that's 100, and reactants are up here and that's 200, well, products are 100 minus the reactants, that's 200. So my answer is negative 100. And so that negative sign, that's the delta H. That negative sign tells me that it's exothermic because my products have lower energy or lower enthalpy than my reactants. So anytime you see a graph that looks similar to this where the products are lower, that should indicate that you have an exothermic reaction. And then anytime you subtract products minus reactants and the delta H is negative, that should also indicate that you have an exothermic reaction. So down here, it just kind of summarizes a couple of things on these bullets. It just says that in exothermic, heat flows from the systems to the surroundings. And so the temperature of the reaction mixture and the surroundings, it increases as heat is released. So exothermic reactions include, it says on here, combustion and neutralization. So we need to know any type of combustion reaction or any type of acid-base neutralization reaction or exothermic. Anything that's burning, anything that's giving off heat, anything that feels warm to you is considered an exothermic reaction because it's releasing heat out to the surroundings and you can feel that heat, okay? Endothermic, the graph basically looks the opposite. On this one, my reactants are down lower, my products are up higher. And so now if I look at the arrow, it's pointing up. And so now the products are up higher. So if I go back to my thing, you know, if I label this like 50, 100, 150, 200, and then maybe the products are here at 250. And so now if I were to subtract, if my products were, you know, around 250 and I subtracted where my reactants are around 100, now the answer is positive 150. So my delta H is positive, and it's positive because the products have a higher enthalpy and therefore the products are less stable. So endothermic reactions don't always occur naturally because the whole point, like most of our chemicals, like they want to be more stable. That's the whole goal of everything. All of our atoms, all of our molecules, they want to be more stable just naturally. And so endothermic reactions don't really happen naturally very often. Usually we have to do something to make them happen. And so exothermic reactions are much more likely to happen because your products end up being more stable than your reactants, okay? So here it just kind of summarizes again that heat flows from the surroundings to the system. So you're absorbing heat and putting it into your system, into your products. The temperature on this one, it decreases. So this is going to be something that would feel cooler. And so if the temperature decreases, or if you feel like your beaker or whatever you're doing your reaction in and it feels cooler, then that tells you that it's endothermic because the heat's being absorbed and it's being changed from heat energy into chemical energy to create new bonds and make new products, okay? So some big examples of endothermic is photosynthesis, and anything that's decomposition, anything where you are, it's thermal decomposition. Photosynthesis is a big one though, because you're taking light energy and you're taking water and carbon dioxide, and you're converting it. Plants convert it into oxygen and glucose. That's their sugar. So they create sugar from it, and it's in order to feed themselves, to create their own energy. And so what you have here kind of on pages 7 and 8, you have a table where it wants you to summarize kind of the differences we just talked about between exothermic and endothermic. So in terms of enthalpy change, like how would you describe each one? Which one has lower enthalpy? Which one's more energetically stable? So would that be like the product or the reactant? And then is heat absorbed or released on each one? And then underneath you have some exercises where you're kind of defining some stuff. It's having you sketch one of those diagrams for exothermic and endothermic. And then there are some practice questions that are multiple choice, okay? So which statements about exothermic reactions are correct? And then there's one about endothermic. So a lot of them are about endo and exothermic. Here's one that has a picture of one of those diagrams. It looks a little different from the one in our notes. It doesn't just have straight lines. It has kind of this curve. That's fine. I can still see that like here are reactants and here are products. So I can still see that one is higher and one's lower. And I can use that to figure out if it's endo or exothermic, and then if the delta H is going to be positive or negative based on which type it is. And then that's where you will stop, because we will be picking up with the next part on Thursday.